Hi, and welcome to this course on how to develop a FPGA-accelerated application with Xilinx XDXL. I'm Marco Santambrogio, Associate Professor at Politecnico di Milano, and with Marco Rabozzi and Lorenzo Di Tucci, I do have the pleasure of teaching you this class. Today, we are going to start together a terrific journey, or if you prefer, a sort of hitchhiker's guide to SDXL. We are entering an era in which technology progress induces paradigm shifts in computing. As a trade-off between the two extreme characteristics of GPP and ASIC, we can find a new concept, a new idea of computing, the reconfigurable computing, which has combined the advantages of both the previous worlds. Field programmable gate arrays, or from now on just for simplicity FPGAs, are a particular family of integrated circuits intended for custom hardware implementation, with the key property of being capable of reconfiguration for an infinite number of times. Currently, FPGAs are the state-of-the-art of programmable logic devices, and this is the reason why this course is focusing on distributed systems based on these particular chips. Within this context, we can say that reconfigurable computing will widely, pervasively, and gradually impact human lives. Hence, it's time that we focus on how reconfigurable computing and reconfigurable system design techniques are to be utilized for building applications. Within this context, programmable logic devices provide an alternative growth path that allows application specialization while benefiting from the full effects of commoditization. Like microprocessor, modern reconfigurable logic designs can be employed in a wide variety of applications. On one hand, reconfigurable computing can have better performance with respect to a software implementation, but paying this in terms of time to implement. On the other hand, a reconfigurable device can be used to design a system without requiring the same design time and complexity compared to a full custom solution, but being beaten in terms of performance. Application acceleration and system adaptation can be achieved by specializing the reconfigurable logic in the target system or application. This has led to a new concept for computing. If a system can be built with one or more FPGA-like devices, it could in theory support a specialized application-specific circuit for each program, or even for each stage of a program's execution. Given the architecture and the design flexibility, reconfigurable computing has catalyzed the progress in hardware-software co-design technology and in a vast number of application areas such as scientific computing, biological computing, artificial intelligence, signal processing, security, control-oriented design. This is just to name a few. It is not guaranteed that in these applicative domains we are going to have the presence of an hardware design expert. This means that we have to work towards the definition of a reconfigurable friendly ecosystem that will make these technologies open to everybody who is going to find benefits in using them. This is exactly the case of the Xilinx SDX environments. The Xilinx SDX tools, including the SDXL environment, the SDSoC environment, and Vivado HLS, provide an out-of-the-box experience for system programmers looking to partition elements of a software application to run in an FPGA-based hardware element, and having that hardware work seamlessly with the rest of the application running in a processor or in an embedded processor. The out-of-the-box experience will provide interesting and, let us say, good enough results for many applications. However, this may not be true for you. You may be looking for better performance, data throughput, reduced latency, or to reduce the resource usage. This course is focusing exactly on this. After introducing you to the FPGAs, we are going to dig more into the details on how to use Xilinx XDXL, providing you also with a working example on how to optimize the hardware logic to obtain the best of your hardware implementations. In this case, certain attributes, directives, or pragmas can be used to direct the compilation and synthesize of the hardware kernel or to optimize the function of the data movement operating between the processor and the hardware logic. In the following classes, we are going to focus on distributed heterogeneous infrastructures. Therefore, after a brief introduction to FPGA device, we are going to dig more into the details on how to use Xilinx XDXL, providing you also with working examples, and on how to bring your solution to life by using the Amazon EC2 F1 instances. This is it so far, and once more, welcome to this new course.